Alright everybody, I think we're going to knock out 2 problems in one video because I think these ones are going to go quicker. So, number 6, we have 2 graphs here. We have g of x and f of x, and it's telling us that h of x equals f of x divided by g of x, okay? So, we're going to identify where the values where h of x equals 0. So, as we know, when we have a function that is a fraction, we're looking for the numerator being 0 when the denominator is not 0. So we're just going to look for where f of x is 0. So we come to f of x, here it is. It's this curve. So it's going to be 0 when the output, the y value, is 0, which means we're looking for where it intersects the x-axis. So it looks like it happens once here at -2 and then once here at +2. So we say the values where h of x equals 0 are x equals -2 and 2. Those are our 2 zeros. Okay, now we're going to state the domain of h of x. So once again, with domain, we're looking for all of the x values that work, but there's infinite number of x values, so we're just going to look for the ones that don't work. And the x values that are not going to work are the ones that make g of x equal to 0. So we're going to look for the x values that we can see in this window where g of x is equal to 0. So it looks like it only happens here at x equals 0, bounces down, who knows what happens after that. So we will say that the domain of h of x is -infinity, or, one sec. Okay, sorry, I'm back. So I had to make sure I was interpreting the problem correct. Alright, so we're actually just looking in the window we can see because we don't know what happens beyond this point. We don't know what happens beyond this point. And same thing down here. There's no arrows on these graphs, right? So we can only look at what's happening in this window. Alright? So all we know is that, and it looks like it even stops right here, right? It looks like it stops right there at -3. It looks like it stops here at 3. So what we can say then is that the domain is -3 to 0 union 0 to 3. Okay, -3 to 0 and then 0 to 3. Okay, so we haven't had one like this, and 3 is included. We haven't had one like this before, so we have to use a little bit of critical thinking. When we do set builder, normally we say x is a real number because we're saying it can be any real number we want it to be, and then we put some restrictions on it. But in this case, x doesn't span throughout all real numbers. It doesn't go from -infinity to +infinity. It just goes from -3 to +3. So what we say is x is between less than or equal to -3 and then, or greater than or equal to -3, less than or equal to 3. So we say x is between -3 and 3. That's what we're saying there. And then we just say but also x cannot be equal to 0. And that is our domain. -3 to 3, but also x cannot be equal to 0. Or we say that it spans from -3 to 0, and then from 0 to 3, and then -3 and 3 are both included. Okay, so now we're going to evaluate g of f inverse of 1 plus 2. Okay, so first let's find f inverse of 1. And f inverse of 1, so we're going to find out where the output is 1. So the original function sent 0 to 1, so the inverse is going to send 1 back to 0. So we know that f inverse of 1 is 0, but we're not done yet. We're not done yet because we have to add 2 onto it. So we get g of 0 plus 2, which is just g of 2. So then we come over to 2, and we say at 2, g is, let's find out, at 2, g is -1. So the answer is -1. Okay, cool. Next, number 7 is going to be pretty quick. If f of x is odd, then we know that the other point that should be on there is -2, -pi. If we plug in the negative of this input, we get the negative of its output, so -2, -pi. Alright? If f of x is even, then if we plug in -2, we get the same output, pi. Alright? Because it's even, it's symmetrical, so if we plug in 2 and -2, we should get the same output. And then what point must be on f inverse of x? Well, the inverse just flips the inputs and the outputs. If the original function sent the input to the output, the inverse sends the output back to the input. So that means if 2 pi is on there, then pi 2 better be on the part of the inverse function. and that one is done. Okay, so make sure you review part B of this problem again, because again, it's different. This function doesn't go all the way to negative infinity to infinity. It just stops at 3 and negative 3. So it's a little bit different than the ones we worked with before.